Thank you. So welcome, Troubleshooting JIRA and Confluence. I'm Jeff Curry, as you all know. So let me start by telling my story a little bit. So before I got hired at Atlassian, all I knew was that Java was slow, bloated, and I never used it. But since then, I've solved about 3,000 support cases, roughly 5 a day since I've been here. So I'm going to show you 3 things that will troubleshoot most problems, and if not, it'll provide the information we need to diagnose your problem further. Next, I'll show you 3 other things that you can do if the first 3 things don't work. And lastly, I'll show you a little ninja trick to how to get support from us faster. And the best way to show you is actually go through a case that was challenging on our end and walk you through the troubleshooting process. This case comes in, this is all we get, a screenshot and an error message. Not a whole lot to go off of. This is also a larger instance, so we have to kind of tread lightly and come up with a workaround so as not to disrupt all the operations going on. First place I'm going to check, logs, Atlassian JIRA.log. A lot of times customers will look at Catalina.out, not the log file you want to look for. Definitely that one. So I'm trolling through this log file. There's going to be a bunch of exceptions. Not all of them are going to be related. How do you diagnose the noise from the signal, or the signal from the noise? If you notice, I've highlighted the classes you want to look for. So you don't want to just look at the error message. You want to look at where this is coming from. So this exact error message is coming from the mail handler. And you can see that it doesn't like the SSL certificate used. Kind of gives you the little detailed story of where the error is coming from. Really not related to our error, so we move on. The log file is actually completely littered with these guys. And at first it looks really scary. Oh my gosh, socket write error, out. It occurs when the browser is closed when JIRA is sending data. So you'll see this a lot. Don't worry, everything's fine. Not what we're looking for. Here we go. First indication of a problem. Let me backtrack and describe this a little bit. If you look at the classes, you'll see JIRA is trying to add a comment. It's trying to add it to the index, and it times out, as all write operations have to hold a log file. Well, this is more of a symptom than a problem, right? It could be multiple different reasons why JIRA timed out waiting for this. So I'm going to go to the next point of information, GC logs. Logs and GC logs are pretty much the best way to get passive information. So you just turn this on, and you don't really look at it until problems are occurring. So it's not enabled by default. These are the flags that will enable it. Don't have a whole lot of time, so I'm going to skip over a lot of GC concepts, but bear with it. This is what it looks like when you look at a plain GC log file. There's a bunch of stuff, not really sure what it means. In the filtered output, it's showing exactly what we're looking for. So all you want to look for mainly in a GC log when diagnosing issues is a full collection, meaning the JVM froze while it was clearing up dead objects. And then we only really care about how long it took. So we see in this filtered output that JIRA froze for 7 seconds, 10 seconds, 15 seconds at a time. What happens is when it freezes and comes back up and resumes operation, all the jobs that were queued come in and just creates more problems. So this is definitely, again, a symptom, not a problem, but we need to solve this first before diagnosing further, because this is causing the application to crash and go down. So we get a workaround going. Basically just tuning GC in such that it stays stable. The catch is that it performs slower. So while this is going on, JIRA is actually going slow, but at least it's up and running for use. Added some more memory and added another CPU to assist with garbage collection. So this actually let us stabilize the instance while we look further. The last hurrah for the 3 basic ones is thread dumps. So this will tell us what the JVM is actually doing. Now, when you issue a thread dump, you'll see all sorts of threads, right? If it's a busy instance, you're going to have 150 of these. The key to look for is if it's runnable. So you see I've highlighted a runnable state. So you don't care particularly what threads are there. All you care about is runnable threads. And you can look at where the classes are coming from. This is course worker, JIRA service runner. Again, looking through the stack, you'll see this is coming from the email handler. And again, from the service runner. This is an actual index thread. So when you hit reindex, do a thread dump, this is what will show. If you look, there's a database call. Any database call is going to be expensive in terms of overhead. It's mostly the first place you want to look for performance problems. Again, indexing thread, an indexing thread. Now, truth be told, I wasn't able to reproduce the exact thread that I saw. However, it looked something like this. JIRA going through a pop inbox, looking for issue keys to create a comment, and it was making a database call. So you multiply this out by thousands, and that's when we see JIRA spiking the CPU, garbage collecting, all that jazz. Resolution was simple. All you need to do, remove all the mail from the mailbox. Something seemingly unrelated was causing JIRA to crash and go down daily. All they had to do was clean up the mailbox, as they had unrelated messages relating to the JIRA issue handler. Next, how you can take this further. So you're looking at the log files, error's not there, poor performance. Visual VM is a tool that I use on an individual basis when those three things fail me. Gives you a nice little interface into what the JVM is doing, and it'll allow you to take thread dumps and actually heap dumps where you can analyze objects held in memory. Let's say you look at Visual VM and everything's kosher. The next step you want to look for is OS monitoring. And this is actually a tool that we use in our hosted environment called SAR. And if you just type SAR, it'll show you every 10 minutes what the CPU utilization was, disk I/O, network traffic. If you want to know more, that's where to go. But where do you turn if performance problem is occurring? JVM looks good, OS looks good. Well, the last step is networking. So these tools will allow you to look at it on a network level where timeouts are occurring. Maybe you have an icon on another server that's not sending it to JIRA fast enough. What these tools will allow you to do is break down the actual paid load times and provide statistics for when the page renders in JIRA. Now let's say you do all this and you don't have any idea where to turn. Well, there's a couple options for you. First step, probably the most fastest method, is self-help. So we provide a lot of tools that will allow you to do this yourself. The best one is obviously something we roll into the products themselves called the Support Tools plugin. What this does is it scans your log files for known exceptions in our knowledge base. The catch is that the application has to be up for you to use this. However, if you file a support request, Hercules will scan your log files that you attach to the support issue. Next, if let's say you check Hercules, nothing there, knowledge base articles, answers, there's also a super secret ninja channel on IRC Freenode. And my personal favorite that I use all the time, Googling. And you can see here, you just keep it generic. You can even use quotes. And more than likely than not, the issue is already known, and you'll find, and look at this as the first hit. Okay, Jeff, I did all that. Now what? I still didn't get my answer. Here's the catch. In our support site, we only guarantee initial response times, not resolution times. The problem is that when you submit an issue, more often than not, we don't have all the information we need to diagnose your issue. So the first IRT, or we call initial response time, is wasted asking you for more information. Give me your log files. I need a screenshot. Social security number, date of birth, all that fun stuff. So there's a recipe in how you can do this. Kind of Mad Lib this out. When I do X, I expect X. However, this happens. Here's my log files. Here's my screenshots. Here's how to reproduce. Don't assume that we know what you're talking about. Just treat us like a child, basically. So for example, this was my support ticket. Filed this right from the get-go. So I attached all information. Even if it's too much information, better too much than too little. What this will do is it'll force us to actually investigate the issue in the first bounce and get back to you within those published IRT times. So instead of having to wait a day or so, back and forth of getting proper information, we have all that to go from, and the first bounce, more often than not, will be a useful one to point you in the right direction. In summary, you have application log files, GC log files, thread dumps. If that's not enough, you go to the next thing, Visual VM, OS monitoring, HTTP inspection. And if all else fails, support.atlassian.com, attaching all the information that you produced, going through this. I expect you all now to be experts, and anyone can ask you anything. Thank you.